We will start with building Apptainer containers, so building them yourself. So there are multiple ways to install your container. You can do it interactively. Interactively is a recommended way when you don't really know on beforehand how you have to build it. So when you do it interactively, then you can try things and see if it works. And if it doesn't work, try things again. And that avoids that you have to repeat the cycle of building from scratch everything again. But once that you know how to build it, then it's recommended to use the Apptainer definition file, which gives you step-by-step instructions for Apptainer how to build it, so you can build it in a reproducible way. So if you have to rebuild it again, you can just take this Apptainer definition file and build it in exactly the same way as before, or at least as similar as possible. There's also a third way. If you know Docker, if you know how to write Docker files, then you can also create first a Docker image and then convert that Docker image to Apptainer if you want. That's also an option. And then the fourth option is to use the HPC container wrapper. This is a very convenient tool if you want to build container images with Conda packages or with pip packages, which we will see later. And then if there is some time, I will discuss a few more advanced topics like building for GPUs, MPI, or performance optimized containers. And then maybe also discuss a little bit use of Podman in HPC. Okay, so first things you have to do is again do the preparation and set some environment variables. So this is Apptainer underscore cache dir, which is the cache for Apptainer, and Apptainer underscore tmp dir, which are some temporary data for Apptainer. So as I've written here, it's recommended to add this to your .bashrc so you don't forget about it. Okay. And then here are some instructions for building interactively. So we can try to do that again. So let me first remove the containers that we already have. Apptainer build -- sandbox. So we will build a sandbox container from the Ubuntu image, the Ubuntu Docker image. Yeah. So what we have now is this directory, my sandbox, and this directory contains our container image, but it's not a single file, it's all files separately. It's a file tree of our container, and we can run it as such as well. So we can just do, for example, we can start the shell inside it. And then here I add the -- writable and -- fake root options because I want to make some changes inside my container. And now it's telling me that it's skipping the mounts because, yeah, you don't need the mounts when you have to build stuff inside your container. And then you can install some stuff inside your container. For example, you can do sudo apt update. You don't have to use sudo, of course. I forgot about that. Then apt upgrade. Now I can install, for example, apt install, let's say Caussay. Boom. Now I can run Caussay. User games Caussay. I am the smart cow in the room. Voila. So now this is all installed in our container. And when we are ready, we can just exit and we can build a final CIF image if we want, right? We can also, and this is a nice thing about the sandbox, we can also access it from the host. So we don't have to start a shell inside our container. We can also just go into this directory. So we can go, let's make it clear first, cd my sandbox. And now we are at the root of the container. So this is the slash. So the first slash of the container contains all these files and directories. And we can, for example, see here the run script. So we can see here singularity run script. So it's here, and we can modify it the way we want. And we can also update the environment files if you want. Sorry, that was wrong. So here we already have a number of environment files defined, and we can make more if you want, right? We can, for example, also update the run script. Let's do that just for fun, because we can. So we are going to remove everything because we don't need it. We can just say, okay, user games say, and this will then just execute say with all the arguments that we provide. Now we can run this thing. So now we can do Apptainer run. We have to first go back out of the sandbox directory, of course. Run my sandbox. And then we can just provide a string. And then the cow will say, you are great too. Okay. And then when we're ready, we can do the final build of the sandbox. Okay. So now we have created the myimage.cif, and this is a immutable image, so it's sealed, it's locked, you cannot change anything anymore. And we can also run again say using the CIF image. Right? So once we know how to build it, we have written all the steps that we need to do to get it running. Then we can create our Apptainer definition file. And I've already created a definition file for you for building the TB-Lite demo example that we showed this morning. So you can find it in the GSSI training repo if you want. So let's take a look at this file. So the first thing in this file says, okay, it's a Docker image that we will pull. It's a Ubuntu 24.04 version. This is taken from Docker. And this will be the base image that we will build upon. Yeah. Then below there are a number of sections. The sections starting with the percentage. And so the first section is arguments. Is an optional section. You don't need to use it. It's very convenient because here you can define some variables that you can then use in the rest of your definition file. so you can use them as templates. So I can, for example, set conda base. So this is the base directory where conda will be installed, the installer script, and the TB-Lite version I have defined here. And here with curly brackets, you can here specify these variables below. Then we have the environment. The environment section defines the environment variables that will go into the environment scripts in your Apptainer container image. So here we will set the path to the path of your conda environment, so that we are able to find the conda executable, right? Then we have the post section. The post section is the most important one because here the actual building and installing will happen. So this is just all shell scripting. So it's typical echo commands, apt-get commands, wget, and so on. So first we will update and upgrade our Ubuntu installation, so to be on the latest one. And then we will install wget because we want to use wget. As I said, Ubuntu image is very minimal, so anything that we need will have to be installed. And we want to download the Miniforge installer here, right? Then we will actually install Miniforge using the installer in the conda base directory. And then, oops, sorry. When we're ready with installing, then we can remove the installer. We have to set the path again because everything set in the environment here will not be executed in the post section. So we have to do it again here. So that's why I'm setting the path again for the conda executable. And then we can create a conda environment with the conda forge repository, and we can specify the conda package that we want to install, TB-Lite Python with a version. And then when we're ready, we can clean up everything that we don't need anymore. And then the next section is then the run script section. This is just normal bash script. So what it will do, it will source the conda environment. So all the executables that we want are available. And then it will exec everything that is put behind the Apptainer run image command. Then we have some optional sections like the help section, but I should put this here. Sorry. But about that, so it's better to do it like this. Anyway, it's not so important. So the help section just prints everything that is below the header. So it's just plain text file that will show you how to run this thing. And then the test section is something that you can run to test your Apptainer image to make sure everything runs as it should. But the test section doesn't run the run script, so you have to manually run it. So you put here the run script before the actual command. Actual command is TB-Lite -- version here in this case. Okay. We have now everything, so we can start to build it. We can, again, first build our sandbox if we want and make some changes, or we can directly build the CIF file. We can also do that. Let's do this, just to save some time. So I hope you can follow. It's quite fast. So now it's installing conda packages, removing the installer, setting the path here. So this is all conda stuff. And then finally creating the CIF file. So you can see that before it creates a CIF file, it will run the test to be sure. You can also disable that so that it just skips running the test before creating a zip file. You can also do it. Okay, it's almost done. And it's finished. And it works. All right. So here are the instructions for how you can use the Docker image workflow. So you have to first create your Docker file, then build your Docker image, then save it as a Docker archive file. Change, of course, the owner of this file because you made it as root. And then with Apptainer build, you can convert your Docker image to an Apptainer image if you want. I'm not going to show that, but if you're fluent with Docker and Docker files, then this is definitely a good way to work. Okay, and then the final tool that I want to show is the HPC container wrapper, which should be installed in most VSC sites. At least it's installed at VUB and Antwerpen. I'm not sure about Ghent and Leuven yet. If it's not yet installed, then definitely ask them because they should install it. Okay, Leuven has it, great. Okay, and Ghent as well. That's perfect. So HPC container wrapper is very useful because it's very easy. It automates everything for you. The only thing that you need is a Conda environment file, a YAML file, for example, this one to install TB-Lite Python. Or you can also provide a Python requirements.txt file for installing with pip. So here I will show it with Conda. So you load your HPC container wrapper module with the version that is installed, of course, which can be different from the one at VUB. And then you just execute this command, conda containerize, new, because it's a new container. You set a prefix. The prefix tells you which directory to create and where to put the whole installation. And then you provide your environment.yaml file. Okay, so let's do this. So everything is clear. HPC container wrapper. So we only have one version, that's easy. And then you can execute it, but of course I have to copy first my environment file. Is it? Here it is. Oops. And now we can run this command. Voila. So it will build on a Rocky Linux 9 base. And it says, okay, the directory doesn't exist yet, so I will create it for you. To install MiniForge. To create an environment. And then install all the Conda packages that are required. So you can see that it creates a squash FS image. So it's actually not modifying the initial container. So the base container, it's not modifying it, it's just creating an extra layer on top of this. which makes it easy to modify it afterwards. Yeah, voila. And now it's ready, and it tells me, okay, just change your path environment variable to be able to use this thing. So let's do that. Let's just copy what is here. And now I can just run tblite. What happened now? So we didn't have to do Apptainer run or anything. It's just there. So the magic that is happening here is the wrappers. So HPC container wrapper contains just a bunch of wrappers that just will execute Apptainer behind your back. So you don't have to care about this anymore. Let's see how this works. So everything is in my tblite directory. You can see here the bin directory contains all these executables, and all these executables are wrappers. So you can see that it automatically creates the tblite executable wrapper for us. We didn't tell it like, oh, there is a tblite executable inside. Create a wrapper, please. No, it just finds it out. Okay, there's a executable created, so I can make a wrapper for you. And also there's a Python wrapper as well. So we can also just run Python like this. Or let's just check. Let's just check where is Python located. Okay, it's in our tblite directory. We can check which version it is. So it's a different version than the one that is used in our models. So you can see the Python here. Where is it? So it's a different version. So that shows that indeed it's using the Python from the container and not from the models. Now, of course, it's better to do ML purge first to avoid that there's any conflicts between the models and your container. And then we can just run this like this. You can see here the full path to our tblite Python bindings. You can see that the path is starting with local underscore Tiki. So Tiki was the original name of the container wrapper project. Okay. It's my time. Ja, 10 minutes. So, yeah. Yeah, ask.
Like for these wrappers, would it be possible to also let it add automatically some bind mount paths by default, except just the directory where you're in?
Good question. I don't know. Maybe it could be. I'll check for you. Yeah. That would indeed be nice. Yeah.
Yeah, there's a question in the chat as well that maybe you can do it now as well.
Yeah,
So the
sure.
question is, once you create the image with the Conda environment in it, is it read-only or can you dynamically add additional packages afterwards?
So with the HPC container wrapper, you can indeed add extra packages, which I'm showing now in this slide. Yeah. So this is an example where you create an update.sh script where you can put whatever you want. Here in this example, I'm installing an extra Conda package, beautiful soup, and then I'm installing the regress package with pip. Of course, Steven told us it's not a good idea to mix pip and Conda, but I'm just showing it here so you know it's possible. And then once you've created it, you can just update your container with this command. So You can try this for yourself, but it should just work. Okay, let's quickly go over GPU-enabled containers, and GPUs are used more and more. And although it's a bit out of scope for this training, I think it's quite useful for you to know how to build GPU-enabled containers. So there's a few things that you have to be careful about. One thing is that the apps that are installed in your container, they must match the GPU of the host and the driver. So the CUDA version that it was built with inside your container should be the same as the CUDA version that is loaded on the host. Yeah. So how you do that? Well, the simplest way is to check all the models that are already available in the cluster and use a CUDA version that is there, and then you will be sure it will also be compatible with the NVIDIA drivers on the cluster. Yeah. Another thing is what we recommend is start from a container base that already contains the CUDA libraries. For example, from the NVIDIA container registry, which is very nice because it's optimized for NVIDIA GPUs. And also it contains instructions for many different types of NVIDIA GPUs. So you don't have to specify this manually. It will have like a fat binary of all the CUDA compute capabilities. And then the last thing that you have to be careful about is the libc version inside your container. Shouldn't be too different from the libc version in your host. libc is like a base library that is needed for your software to run. So it's part of your operating system. So what you should do then is make sure that, the OS version in your container is of a similar generation of the host, and then it should, in most cases, just work. Okay. MPI-enabled containers. This is a bit out of scope also, but note that it's definitely possible to create MPI-enabled containers. There are two ways to do this. There's the hybrid model and the bind model. In the hybrid model, you install an MPI library inside your container, but you have to make sure that this MPI library is compatible with the MPI library on the host so they can talk to each other. And then this is the command that you use. So you use MPI run or srun if you want, if that's supported on your cluster. And then you just run Apptainer exec within your MPI run prefix. Or you can use the bind model where there are no MPI libraries installed in your container. And then you bind mount the MPI libraries of the host into your container. So that's why you have this --bind option here. The MPI directory which contains all the libraries is bind mounted into the container. Okay, and then some performance optimized containers nodes. So this is again the trade-off between performance and portability. So yeah, if you want to have the best performance, then you should install from source. You have seen already several ways that you can do this, especially the talk of Cynthia, but also the talk of Kenneth after me using EasyBuild or spec are especially useful in this regard. And then also please check the VSC trainings on how to use all these tools like make, CMix, and so on. And there's also a special VSC training on containers for HPC also. This is worth taking a look at. And then finally, some notes about Podman. Podman is already installed in the clusters of Leuven, I've been told at least by Steven. And he told me also that I can tell it to you so you can just use it. And as you can see in the table, it's quite useful to use Podman because it can be run rootless, just like Apptainer. It also runs daemonless, so there's not like one daemon that has to constantly run in the background. It can also build directly from a Docker file. So if you know already how to write Docker files, then this is very useful because then you don't have to learn another Apptainer definition file format. It also has Docker-like commands, so it's very compatible with the Docker commands. And it can also run directly Docker images. The downside is it's not a single file and it doesn't have any HPC integration. So it can do all these integrations, but you have to specify all these things manually, set up the network so it can find everything and so on. So, okay, so that's, yeah, and then I have some homework if you're up to it. So it's again building Alpa in a container, but you can choose however you want to do it, depending on how confident you feel. If you have not too much confidence, then take the easiest route, which is the HPC container wrapper, or you can write your Apptainer definition file, or you can do it via Docker. And then Alpa itself can be installed inside the container also in different ways. You can do it with Conda, that's the easy way. You can do it with EasyBuild, that's the a little bit harder way, but then you will get more optimized builds. And you can also do it manually, like Cynthia showed, of course. And then when everything is installed, you have to make sure that this command will work. Voilà. And here is some more documentation. So we have a special Apptainer documentation section on the VSC docs, which is not yet complete, but we're working on it. Okay. That's it for me.
Right. Any questions for Sam on building your own container images? Yeah.
Thank you for the introduction to building these containers. I was wondering in terms of documenting, I like when I have the result of analysis and the project's finished, I have a way of saying that these were all the versions used. You show that you can use it like a Conda-like environment file. Is it stable and reproducible? If I use such a file, just put it there, and then 5-6 years, someone's going to build the container again using that same file? Or you just say, build the container, it takes a bit more space, but then it's stable for a longer time?
Good question. If you want to keep it as reproducible as possible, then you should just keep your container as the image and save that one. You can indeed create a reproducible recipe with Apptainer definition file, but that depends on what you write inside your definition file. Because if you don't specify the exact versions, for example, that you want to build, yeah, then it's not going to be reproducible. Because if you say, okay, just build the latest version, then yeah. So it depends on how you build it. Yeah.
And you're also downloading stuff from the web. So if that stuff disappears 5-6 years from now, it's game over. Yeah, there's nothing you can do to fix that.
Yeah, that's also a bit of a danger with Conda. If you want to install old Conda packages, it's not guaranteed that they will be still available online. Yeah.
Another question in the chat. What if you tool, I guess it's your tool, what if a tool in your container needs another CUDA version than your host? Is that possible in any way?
Well, CUDA versions are compatible, but not infinitely. So there are ranges of compatibility between different CUDA versions. So you should check the documentation on the NVIDIA website. Yeah.
So there, I guess when you're using GPU software in a container image, you should be able to use it for a while, but over time, as the GPU drivers are updated, at some point it will just break and no longer work.
Yeah, and that's also the same for the OS version. It needs to be similar to the host, so they're also stuck.
And then another question, how can a container or an app inside the container run across multiple nodes using Slurm? Should Slurm be defined and slurmd be installed inside the CIF file?
No, no. You don't need any Slurm stuff inside your container. As I said, if you want to run MPI applications with MPI, you're able to run on multiple nodes. Then you have to make sure you have installed MPI libraries inside your container.